Hello, my name is John Ryan, and I'm going to show you my Comp 361 final course project. This was a solo project, and I, before this, had not taken any AI or machine learning courses. So I will do a little demo here. So basically, it's a robot simulation. Of the main topics that were available in the syllabus about what this is like a human robot interaction type of idea. So basically, imagine an e-pet, like a robot pet, in a house. That's the main big idea here. So I have a simulated house that I built. You can see how there's these 4 different rooms here. So on the top left, we have the kitchen. Top right is a living room. Bottom left is an office, and then bottom right is a bedroom. This little blue guy right here is our robot, and the red here is the direction he's facing. The black tiles are walls, so you can see they're separated with little hallways here. And the white tiles are free space. The orange, so not orange, the brown are a table, or are basically table objects. The pink is a couch. The yellow is a desk, and the purple is a bed. You can see there is information kept about the robot, so its position relative to the grid space, the direction it's facing, and then the room it's currently in. And on the legend over here, I have very clear all of the commands that I've implemented. So I'll just show you one because it's pretty cool. So if I say go to bed, what it's going to do, whoops, I hit backspace by accident, it'll go to the nearest object of that type. So in this case, the bed is down here, right? And it can't actually go into the node of any of the bed because that's not free space. So it's going to go to the closest adjacent one that it can get to. So if I see this, you can see, boom. This is using A star. The heuristic is the Manhattan distance. And you can see how it went all the way from the top left there to the bed. And you'll notice I implemented a log here. So this basically keeps track of the 13 most recent things that the robot did. And it prints them there to the log, which was really, originally was a debugging feature, but I actually liked it so much I kept it. And then down here, you'll notice, oh, that's a little interesting. We got this thing called Rob. So Rob is actually the name of the robot. And if you use the keyword Rob, it activates an LLM, which is model Llama 3 from Ollama. So if I do a little test here and I say Rob, what should I say? How are you today? Question mark. A little second to respond. It says functioning within normal parameters, no malfunctions detected, ready to as assist. The LLM's a little funky. I don't know why it said as there, but normally it's good. The LLM was used as a black box. I didn't build that from scratch, obviously. I prompted it though to understand how it's supposed to respond, that it should be short, that it's named Rob. It's a robot that exists in this house. It doesn't know it's simulated. It thinks it's real, but yeah. I could ask him other funny things. Like, you can ask him whatever you want because it's not, which is pretty cool. So I could say like, Rob, tell me a joke. I want to see what he says. Beep boop. Why did the human bring a ladder to bed? Because they wanted to take things to a whole new level. That is an awful joke. That's pretty funny. So yeah, that was fun to implement and figure out. AI is pretty cool like that. So other commands, I'll go through those. Oh yeah, another thing to note that's super important is Rob uses relative direction. So if I tell him to go a direction, it has to be relative to where he's facing. So I could say forward, backward, left, right. I can't tell him to go north, or anything like that. Like that wasn't part of the design. That's not the point. The point is that it's relative. So if I tell him to go, also if I tell him to go a direction that he's not facing, he'll turn to that direction. So if I say go left 3, he'll turn left and then go 3 squares or 3 nodes, which is pretty cool. If his path is obstructed at any point, he will stop early and he'll tell you. So if I say go right 4, you can see there's not enough nodes. He'll only go 3, and he'll show the 3 of them. And if I try to go that direction again, so if I say go forward because he faces that direction now, it'll say blocked, cannot move, which is pretty cool. If there's not, if I try to make him go somewhere where there isn't a path, he'll just tell me there's no path. That actually is basic with how I implemented this. It's impossible because there's no node that he couldn't get to. Actually, maybe if I try to do a wall, I've never actually tried that before. Yeah, no path found. Okay, well, yeah, because 0, 0 would be the wall. But other than that, there's no way for it, there's no spot that he can't get to, basically, with how this map is set up. Yeah. So commands. So it tokenizes what you type here, like the string, and the words move and go are identical. And if I do move to, it checks if it has move or go, and then to as well. So it checks those. If it's got those, then it knows it's a command to go to somewhere. So I can say go to, and I can give it a room, and it's commanded, it's hard coded to go to near the middle of the room. I give it a specific node. So if I say go to kitchen, it'll go to this node. If I say go to bedroom, it'll go to that. If I say go to office, it'll go to that. Also, I can tell it to go to objects, and it will go to the closest object of that type. So go to desk, it'll go to the desk. Go to couch, it'll go to the closest couch. This is a couch here. Go to bed, this is the closest bed. Go to table, it'll go to the closest table. So it does all that. It's awesome. Yeah, and I can tell it to move, go a direction than any number. I kind of already showed that. I could tell it to go right 2 as an example. I can tell it to turn, so turn left. You can see it rotate 90 degrees here. He's looking up now. Go left. And you can see it also tells you the, oh, I said go left instead of turn left, but you can see when I said turn left here, it says the new direction it's facing when it does that. Yes, that's most of that. Oh yeah, the objects are color coded as it says here. I showed Rob. So yeah, that's the basic simulation to it. Oh, also the status command. I forgot to show that. There's one more command, status. So it'll tell you the position, the direction it's facing, and then what room it's in. Yes, that's pretty cool. All right, so now I'm gonna speed run through some of the code. I only have 3 minutes left, so I gotta go pretty quick here for the 10-minute deadline. Basically, it's a grid, so it's built a 20 by 20 grid. All of them are set to zeros in the way it's represented in the 2D grid. And then what happens is I change the node IDs from 0 to what object they are, and it recognizes those as different objects. So 1 is a wall, 2 is a table, 3 is a couch, 4 is a bed, 5 is a desk. Makes the grid here. Makes the outer walls, that's like the edge, then the internal walls. It gets rid of the where the door should be. I manually made all of the different objects, like the table, couch, bed, desk. Yeah, different rooms. If it's, like I can check the X and Y's. If it's more than this, less than this, and then not the other ones, I can basically determine what room it's in and whatnot. Find object, I can give it an object, and then it will find the position of it, and it will want to go to adjacent if not the, because it can't go inside of it, right? This finds adjacent free tiles. Oh, here's the heuristic. This is the Manhattan distance. Get neighbors, can get like what's beside a specific position or a node. Extract number. So when it tokenizes what you put, when you put n, for example, when I say go to, go right 3, this is how it gets the number. It gets, if it's in a digit, and then it returns that. So that's how it extracts the number from the statement. Get current room. Yeah, A star, here's my A star implementation, pretty basic. Here's interpret, so this is a major thing. So if I have the keyword go, basically it tokenizes the entire command, right? So the string, it tokenizes it by the spaces. If it has go or move and to, that means it knows it's basically a command to go somewhere. So what it does is it gets the word, checks if it's in named locations. If it is, then it sets that to be the target. If it's a room center, like for example kitchen, then it sends that center node I showed earlier. If it's an object, then it will do the find object command. Yeah, turn, checks if that's one of the tokens, and then left if that's another token, or right. That's how it terms that. For moving it, there's the different directions here, and then it basically can figure out the amount of steps. Status, yeah. All right, so I think that's that. Let's quickly. Oh yeah, UI, we'll go through this. So basically, I use Pygame. I'm drawing a grid. I set all the sizes of the different nodes. I basically draw the different nodes, different colors for what it is, like the object, robot position. Yeah, and then, oh, here's the LLM. I'll show this real quick. So I have an ask Ollama prompt. This is the subprocess Ollama. Basically, Oh, I remember this. So I was having weird issues where it was putting random characters that were bugging out like little boxes and stuff. So this gets rid of that. All right, then main. So I have a clock because in the back end it instantly calculates the path, and I wanted to make it so it doesn't instantly do the path. So I have a clock to like basically slow down the visualization of it. Here's the legend. This is text wrapping. Oh, I forgot to show that, but if what you type is too long and it would go off the screen, it wraps it so it's still visible. Oh, here's the prompt. So this is what I gave the LLM so it would understand. I gave it, you are Rob, a robot inside of a house. Only use letters, numbers, faces, and basic punctuation. No symbols or characters. Keep responses short and clear, robot state. And then it's aware of these things because I give it to them. Give it to him in the prompt. And then this is the user's text. And yeah, that's basically it. I'm at 10.5 minutes. I tried to go fast, but it's a lot. So yeah, thank you for watching.